Hey guys, me, Mr. Stanwood again. We are on chapter 5, lesson 3C. And all we're going to be doing with this lesson is graphing equations that are in slope-intercept form. So it should be quick and easy, right to the point. A couple reminders though. Slope-intercept form of the equation, y equals mx plus b. M is our slope, the number out in front of the x is our slope, which is our rise over our run, our rate. And B over here is our y-intercept, our starting amount, the initial value, lots of different terms that we could use for that. So before we just dive right in and start, let me ask you this. What does the y-intercept tell us? Okay, take a moment, take a second, answer the following question, and tell me anything you can kind of think of. What does the y-intercept tell us? Let's see if you got everything that I got, and maybe you got even more. All right, first off, it tells us where the line crosses the y-axis, just where that line crosses through that vertical axis. It tells us the y value when x is 0, which leads us directly to, it's actually an ordered pair, all right, 0 comma b. It's the starting value, all right. Those are all different ideas of what the y-intercept tells us. Next, what about slope? What does slope tell us? Do the same thing, please. Take a moment, type in as much as you can about what slope tells us. Let's see if you got everything again, or you probably got more than I did. But first off, it tells us the rise over the run, how much it goes up or down and over to the right. It tells us how many spaces to go up or down and to the right. That's like I just said. That's what the rise and the run is. And if this is a scenario, it tells us the rate. All right, it's pretty much the unit rate, the rate at which something is increasing or decreasing, or possibly even staying constant. So now, how can we use the y-intercept and slope to help us graph the line? I'm not going to make you write anything, but think about this one for really like 3 seconds. How can the y-intercept help us? And then the slope. Well, if the y-intercept goes through the y-axis, we know that is an exact point on our line on the y-axis. So what we're going to do, it tells us actually where to start. So we plot that point on the y-axis. We plot that point, and then we apply our slope, our rise over our run from that point. That's our starting spot. So we plot the y-intercept, and then we apply our slope, and then we repeat. Okay? So here's an example. Okay, so how do we graph y equals negative 3x plus 2? So the first thing, we need to identify our y-intercept. What is our y-intercept? Hope you got 2. Hope that's what you picked. All right, so what we do is we plot that point. I'm going to plot that point with a smiley because I like using the smileys. Actually, that's a little too big. I won't use the smiley. I'll just use a regular pen at 2. In fact, I want to do red. There. That's the y-intercept of 2. Next, what we need to do is identify the slope. What's the slope? Great. I hope you got negative 3. So our slope is negative 3. We apply that. Starting at the y-intercept, I apply that slope, meaning it's negative 3, but my run is going to be 1. If it's a whole number or an integer, it's always over 1. So that means I'm going to go down 3 from my y-intercept, not from the origin, from the y-intercept, down 1, 2, 3, and I always go to the right one, and I plot a point. I go down 1, 2, 3, and to the right one, and I can continue this forever and ever. If sometimes you run out of room, instead of going down and to the right, which is a negative movement, I could go up 1, 2, 3, and then to the left one, and that would continue on. The last piece that I'm going to do, if we are graphing by hand, we would then connect our lines all the way through the graph. I want to extend it to go all the way through my graph. And that is the line of negative 3 plus 2. Y equals negative 3 plus 2. Let's take a look at one more. Graph y equals 1/3 x minus 4. I'm just going to walk through this semi-briefly. You can pause it if you need, rewind. My y-intercept is -4, so I'm going to go down 1, 2, 3, 4 spots and put a plot pointed there. Oh my gosh, I was struggling to come up with a point. And my slope in this case is 1/3. I'm going to go up 1 over 1, 2, 3 to the right. Always to the right. I'm going to go up 1 over 1, 2, 3 to the right. Up 1 over 1, 2, 3 to the right. And I could continue. Oh, I ran out of room. I could continue this way and go down 1 and left 1, 2, 3. That's definitely enough points. I'm now going to connect my points with a straight edge. I have the straight line tool. If you're going to do this by hand, always use a straight edge, please. And now lastly, what I want to do is let's check out some online practice. How would we do this, let's say, with Khan Academy? So here is an example. Bear with me as it loads. Loading, loading, loading. Actually, this is one of your assignments, is to graph. Maybe you actually get this exact problem. So let me show you how to do this with online. The equation is y equals 4x minus 9. What I'm going to do is I'm going to pick either one of the 2 points that it provides. I'm going to go to -9, since that's my y-intercept. I'm going to drag it down, make sure it's directly on there, and you have to be very careful, okay, that these spots are precise. It's definitely on -9. Now I identify my slope, which is 4. So from -9, I'm going to go up 1, 2, 3, 4, which will be up at 5, and then over 1. Up 1, 2, 3, 4, over 1. And I plot those 2 points, and it makes the line. Let me check. Oh, yeah, I got it. Good work. All right, and that's how you graph online. Your work, your assignments are IXL S7, just graphing, and actually the same exact assignment you saw in Khan Academy. When you're done, check out the mastery check. Good work.